Indoor antenna for reception. This video is informational and not entertaining. This table of contents could guide you through the available topics. Old AM radio receivers are very sensitive to any kind of domestic interference, especially what is produced by switching power supplies, including LED light bulbs. This problem becomes particularly significant in an apartment building where every household has active appliances making electrostatic and electromagnetic noise. The lower the frequency of the noise, the easier it is spread across the power line, with no practical way of shielding against it. Old radio receivers have usually been made for receiving with a piece of wire and sometimes also with a connection to an external ground. Today, to safely connect an antenna that comes attached to a coaxial cable, some attention and possibly some adaptations are required. In general, both terminals of the antenna core and shield should be decoupled with capacitors, preferably with safety capacitors. The value of these capacitors could range between 100 to 100,000 picofarad depending on the sensitivity of the radio, while the insulation should be well above the AC power voltage. These loop antennas have been tested for the medium wave band on different radios. The least effective antenna proved to be the first on the left side, while the most effective antenna has been the last on the right side. However, the loop antennas that seem to offer the best compromise between size and effectiveness are those represented with the letters C and D. The loop antenna C has 8 turns distributed in 4 cm width, in a relatively small loop diameter 40 cm. The loop antenna D has 6 turns distributed in 10 cm width, in a slightly larger loop diameter 50 cm. This antenna uses a thin corrugated pipe 15 mm diameter all along the wire to ensure to have some distance between the loops to reduce the parasitic capacitance between them. The loop antenna Z is made in the same way as antenna D, only that it uses a larger corrugated pipe 20 mm diameter and a larger loop diameter. However, the antennas D and E use both about 10-meter corrugated pipe. Building the antennas D and E with the same sizes but more loops would require a longer corrugated pipe as well as a longer wire and should give better results. However, inserting the wire inside the corrugated pipe could be very difficult if that is longer than 10 meter. To build a loop antenna in the style of antenna D or E, what is needed is corrugated pipe, a cable pulling probe, wire, and hot glue. First of all, the wire is inserted in the corrugated pipe with the help of the cable pulling probe. In this case, 10-meter corrugated pipe is used. A stool with straight and parallel legs will be used to shape uniform loops. One end of the corrugated pipe containing the wire is temporarily attached to the feet of the stool. The corrugated pipe is progressively wound in coils, holding the loops temporarily with thin nylon strip zip ties. When all the loops are arranged in the desired way, some hot glue is used to attach together the loops, without touching the strip zip ties. Then the strip zip ties can be removed and the hot glue gaps could be filled. The hot glue is then used also in the internal part. A hair dryer is then used to get rid of all the thin threads of glue that are not attached yet. Later, with a hot air gun set to a temperature below 200 degrees Celsius, the glue that appears uneven could be adjusted. Then the antenna can be extracted from the forming stool and an antenna base could be prepared. In this case, a large tuna can is used. 7 holes are needed. 4 holes are needed to fix the antenna with long strip zip ties. 2 holes are needed for the 2 ends of the wire to get inside the can. 1 hole is needed for a B and C connector. If the loop antenna is too soft and gets deformed by gravity, a middle pole of insulated material like plastic or wood could be added. A loop antenna is directional, but this receiving direction can be counterintuitive. The pictures show the directions from where a loop antenna can receive a better signal. In an electromagnetic polluted environment, it is important to find the sweet spot where the antenna should be located, where the noise tends to cancel out, orienting then the antenna towards the best source of radio signal. While the best place for an indoor loop antenna is not necessarily close to the radio receiver, some coaxial cable is needed. Typically TV antenna cable and our G58 are good types. However, a loop antenna is not necessarily the best choice for all the bands that one might be interested in receiving. For some shortwave bands not significantly affected by local noise, a simple wire antenna might be better suited. If the coaxial cable is long enough, about 10 meters or more, it could operate also as a wire antenna using a simple switch close to the radio. This is the idea in form of schematic diagram. The cable shield is short-circuited to the internal terminal, opening the connection to the antenna ground at the radio side. In general, the wire antenna would be more sensitive than the loop antennas described here, and the choice of switching to loop would be guided simply by the presence of excessive noise. These videos come with written documentation available from the links appearing under the Show More tab, containing more details and better resolution pictures compared to what a video could offer.